1. Okay, let's look at the simple case of a block resting on a horizontal surface. Okay, this is a horizontal surface like a table, and this is the block resting on the table. Gravity is acting downward on the table, and we always represent that straight down with an arrow as the force due to gravity. Now, you might see it called in some books W for weight, and that is equal to mass times gravity. All forces are equal to mass times acceleration. But more specifically, the sum of all forces acting on an object are equal to mass times acceleration. Okay, this is Newton's second law. Now, gravity is the force acting on the block in the downward direction. So the acceleration, A, is g for this planet. The supportive force we call F sub n. It's the normal force. If the block is resting on the table and it's acting in the downward direction, the force due to gravity is downward, the table has to support the block up. That supportive force is called the normal force. If the normal force were not there, the block would just go through the table. Right? So the normal force is the upward supportive force. Now, this object is not moving. It's motionless. So the sum of the forces in the y direction would equal Fn minus Fg, which equals mass times acceleration. Now, this represents the sum of the forces being equal to mass times acceleration. The normal force is upward, and we normally take it first minus the downward force because they're different directions. One is up, one is down. So the negative sign represents the different directions, and that's equal to mass times acceleration. Now, if the object is not moving anywhere, acceleration is equal to 0, then the normal force minus the force due to gravity is equal to 0. You add that to the other side, the normal force must be equal to the force due to gravity. So in this case, the normal force is equal to mass times gravity.